cosine of 3x plus u. Everybody's okay with the example? Okay. So my first question for you is this. Assume that A is well known. Huh? Assume A is equal to 2. Find u that, I don't know, gives me closed loop system. I'm building the question now. Huh? Closed loop system. 2 minus 1 and minus 2. Huh?
Sir, exam question will be similar.
This is what I'm trying to tell you. That I'm building it right now. I'm building this not now. So you should be able to get the pattern from the questions. Huh? So what controller I'm going to use?
Feedback analyzation.
Feedback analyzation.
Yes.
Okay. A is well known. So feedback analyzation solution here. U is equal to A x2 squared cosine of 3x1 plus V, and you can say V is equal to minus lambda 1 x1 minus lambda 2 x2, and this would be minus lambda 1 would be 2 minus 2, and minus lambda 2 will be minus 3, so it will be here minus 2x1 plus 3x2. Correct? So this would be my controller. How can we find minus 2? You can find it later if we did a mistake. In fact, minus 2 minus 3. You have s plus 1 multiplied by s plus 2. So this will give you s squared plus 3s plus 2. Canonical form minus 2 minus 3. Everybody's okay with this?
Yes.
So done with the controller.
We can't use here backstepping, or it's impossible.
You can use backstepping.
You can use whatever you want.
backstepping. What should I do with backstepping? Another solution, solution number 1. Solution number 2. Backstepping. So we can use backstepping. It's a non-linear controller, so I can say x1 prime is equal to x2. I can put this equal to u. If I'm bothered using x2, I can put equal to u, equal to u1, whatever you want. Huh? So this will be x1 prime equal to u. V is equal to half of x1 squared, which is equal to, which implies that v prime is equal to x1 prime times x1.
Yes.
x1 prime times x1 is u1, so you don't confuse this with this u. u1 multiplied by x1. In order for this to be negative, I select u1 equal to minus lambda x1, minus lambda 1 x1, let's say. Huh? You agree with this?
Yes.
Anything not clear up to now? Okay?
Yes.
Then I come back to my equation here again. x1 prime equal to x2 plus lambda x1 minus lambda x1. So this will imply that we have x1 prime is equal to minus lambda x1 plus x2 plus lambda x1. And this I can call it z or zeta or whatever you want.
So just one question. For V, you choose this input because you said for of closed system is -1 and -2, right? So why we don't choose it like as square plus 3s plus 2? Why this lambda 1 x1 minus lambda?
We are all one, صح? Everybody understood the question, full friend? Can you repeat your question?
So I didn't.
1 plus. 1 plus.
I didn't understand why we put V that way. We
Why
can
we
just
don't put V? Why we put V equal minus lambda x1 minus lambda x2, and we put minus 2 minus 3
Which one, in feedback generalization or
after feedback analyzation? Yeah, after feedback analyzation.
It's state feedback.
State feedback.
It was very close to.
And the system is, so if I go back here, based on this V, I can write x prime equal to 0, 1,
Yeah. Zero.
which is x2 minus lambda 1 minus lambda 2 multiplied by x plus b, which is 0, 1 multiplied by u, صح? Or reference or whatever it is. Dynamic is here. This is canonical form. The canonical form, if I have a system with the characteristic equation s cubic plus 3s squared plus 2s plus 1, and somebody asks me to build the canonical form, it will be this way. 0, 1, 0, 0, 0, 1,
minus
and then I take the coefficient
minus one,
minus 1, minus 2, minus 3.
Yes.
This is the canonical form. So this is how we wrote it.
Okay,
here.
got you. Thank you.
Any other question?
By
Clear?
building like this canonical form, it should be controllable fully, no?
Canonical form is always controllable.
Controllable. Or
Canonical form is always controllable. It's called
controllable canonical form.
controllable canonical form. So it has to be controllable. Okay, I don't have to check it. If I put it in this one, it means controllable. Any other question? Done with the first example? So we go down. So next step, zeta prime. Huh? So zeta prime is equal to x2 prime plus lambda x1 prime. x2 prime is given by minus a x2 squared cosine of 3x1 plus u. X1 prime, or lambda times x1 prime, and x1 prime we put equal to x2 here, right? So I can put here plus lambda x2. Do you agree with this? Fine. So now I go to find u. Same thing. So my v, the up and up, will be the previous v that I took, half of x1 squared plus half of zeta squared. So this will imply that v prime is equal to x1 prime times x1. Okay. And x1 prime is equal to, according to my equation, this would be equal to minus lambda x1 squared plus zeta multiplied by x1, or we can also separate it. X1 times x2 plus lambda x1 squared. Right? So this is only x1 prime times x1. Then we have x2 prime times x2. Zeta 2 prime, sorry, times zeta 2. Zeta 2 prime is equal to this part minus a x2 squared cosine of 3x1 plus u plus lambda x2 multiplied also by zeta. Okay? Zeta prime times zeta. Zeta prime squared. You are okay with this? So what I need to find now? The value of lambda, the value of u, right? That will make the system negative. So I will cancel this. I will cancel this if I want. I will cancel this term, right? And then I will put minus lambda zeta, minus lambda multiplied by zeta. So it gives you zeta squared. Like what we did before in class. You agree with this? Yes? طيب, now I change the problem. Assume that I don't know A. So assume A is changing. What should I do?
Adaptive feedback.
Adaptive.
Because here A it's constant or it's
Huh?
changed or what?
Sorry?
Unknown, just unknown. A or
Changing.
What do you mean change?
Big time.
Change,
With
it's
the
not
time.
a fixed value, it can change based on use, time, whatever it is. Okay, changes. What should I do?
Adaptive
Adapt.
feedback.
Yes.
So I do exactly the same thing. I can use, just for the sake of time, feedback linearization again. So my controller will be equal to minus a x2 squared multiplied by cosine of ax1.
Yes, we.
This plus, right? Minus lambda 1 x1 minus lambda 2 x2. Right? This is my control using feedback linearization. But because a is not known, then I need to put here a, the estimate of a. Right? So the controller can be visible. I replace this in my system. I will have x1 prime equal to x2. x2 prime is equal to minus a hat x2 squared cosine of 3x1 minus lambda 1 x1 minus lambda 2 x2. This is my new system. Okay. And we have here a tilde is equal to a minus a hat.
Okay.
Okay.
Everybody is okay with this?
Yes.
What will be my Lyapunov? B
Half x1 square
half x1 squared
plus 1 over
plus half
2 zeta
80.
No, no.
gamma
Eight
A
square.
square.
Eight.
8 square.
80 square.
Is it a square? Divide 8 of zeta.
Zeta.
Okay, repeat. What's V?
Half x1 squared plus half x2 squared
Half x2 squared. Why half of x2 squared?
because we have two states.
We have two states. The system here will be in equilibrium when the two states are zero, x1 prime 0 and x2 prime 0. If you put Lyapunov only a fraction of x1, x2 can be anything.
And it can be anything.
So it's maybe you are going on the y-axis and you are
No.
think that you are stable. Plus 1 over 2 gamma
A
A
tilde
tilde
squared.
squared. طبعا هنا we put x1 squared and x2 squared. In general, if you go back to your slides, you will find x transpose px, right? But p here is the identity matrix.
Okay.
Or half, you can put here half also. Or sorry.
So, Doctor, E can be any symmetric positive matrix.
Any symmetric matrix. And the existence of this matrix depends on the stability of the system and the selection of Q. If the system is stable, P exists. If P exists, then the system is stable.
So the first thing we select Q, then
Yeah,
from
and you find P. You should be able to know that and to do that. Not only know, but do. طيب. Plus half of gamma A tilde. Here we are using only one parameter. If we have A sine, A cosine, A which are A1, A2, A3, and all of them are unknown, then we would have A transpose A. And then for each
Matrix.
one of the variables,
Make it
we need to find the adaptive equation or the adaptation rule.
simple.
What I'm saying makes sense for you? Yes, clear?
it will be in that case plus half gamma multiplied by A1 tilde plus half, I mean the Lyapunov function,
Yes.
plus half gamma multiplied by A2 tilde.
Exactly. All of them. Or you can write it as A tilde transpose A tilde. And then you have here 1 over 2 gamma. Or you can have gamma here in between if you are going to use
Like a weight.
different gamma for different A's. So it will be A transpose gamma, the function, the capital gamma, multiplied by A tilde, and gamma is selected diagonal
Yeah.
like a different weight. Make sense?
Yeah.
Next, sorry,
V
Derivative.
derivative v prime is equal to x1 prime x1 plus x2 prime x2. I'm going to p equal to the identity matrix. If p is not the identity matrix, then you are going to find the stability condition, which is A transposes p plus PA is equal to minus q. This is not squared. This will be prime times x2 plus 1 over gamma a tilde prime a tilde. Alright, next.
Substitute x1 prime.
You put x1 prime and x2 prime.
You put x1 prime and x2 prime. Right? So we compute x1 prime and x2 prime. What else?
Sorry, excuse me, sir.
Yes.
So you mentioned talking about a transpose P plus PA to be equal to minus Q. Isn't it the assumption that we are working with a linear system?
This is a linear system. Yeah. x1 prime, not a linear system. But this system can be written. In fact, I can transform it by putting minus lambda 1 and minus lambda 2 to a times something plus the nonlinear term. So this a can be there. Can be in the system here. The system is nonlinear. You are absolutely right. But the system is composed of this. If I replace my control signal there, it's replaced here. I will find 0, 1 minus lambda 1 minus lambda 2. Right, like this. x1 prime is equal to this times x plus this term multiplied by a tilde, so it will be 0, 1, a tilde or minus a tilde times, I will put a tilde outside, x2 squared cosine of 3x1, and then I will put here minus a tilde plus b, which is 0, 0, 1, there is no b. So this is your a that will appear there in the dynamic. And this will appear there in the b. Plus something that multiplies the nonlinear term, that multiplies a tilde.
But just confirm, so since the states are also multiplied with a, I mean in terms of cosine x1 and x2, wouldn't it still affect the stability of the system or the
It will affect
convergence
the
of the
stability of the
states?
system. But now we will take a tilde prime to do what? To stabilize it and kill all the other terms that multiplies a tilde.
Take it to 0.
So when you develop, you will find a tilde that multiplies a tilde prime. This is unknown. This is what we try to determine. So you select a tilde prime to cancel this term.
It's like feedback linearization somehow. لا بس هنا you have to pay attention because you are looking to the adaptation rule, not the controller. So I cannot talk about feedback linearization. The control that I'm designing is using feedback linearization, but a tilde prime is the adaptation rule for the parameters. Alright? For the estimation. This is why I stopped. I did not say yes or no. But we try to find one solution, which is a tilde prime that cancel all the derivation term. Make sense for you? Yes? طبعا calculation here will be a little bit long because you are going to multiply all the x's with the stuff from the derivation that you are going to have. And then you are going to select a tilde that cancel all the terms that is multiplied by a tilde. So you can continue the derivation yourself. Make sense? طيب. What if the problem says A is not known, but I know that A is bounded. Either absolute value of A is less than 2, or A is between -1 and 2, or -1 and -2, or whatever. So what controller we are going to use?
Yapon along the first sliding mode.
Sliding mode.
Yes.
This is what we have seen in class.
sliding mode controller. There are other controllers, robust controllers, but this is
The best
for
part.
us. We saw only sliding mode. Okay. Have you seen the difference between the questions?
Yes.
A known, A not
Changing.
known, A can be estimated, A is
Bounded.
bounded. Huh? So here sliding mode, what should I do?
We define as surface. But
So sliding mode, I need to define the surface. So here we are assuming that the value of x desired from the beginning of the questions, I'm assuming that the desired value is 0, 0, right? This is why I told you x will go to 0 and x1 will go to 0. If they are not equal to 0, then we need to modify the dynamic to include the desired dynamic, correct? Right.
how we will put like x desired plus something to make it like put it near to 0 and we will work at 0. Like changement variable.
Change of variables.
Yes.
Yeah, but you just add minus x desired prime and x desired prime from the other side. It's just a constant feed you get in the system. But you take it into account in your control design. For example, I can come here and say I have x1 should be equal to x1 desired. So this is my target, huh? And x2 should be equal to x2 desired. The first thing I need to pay attention to when somebody gives me a requirement like this is that x2 desired is satisfy this equation. So x1 desired is equal to x2 desired. Right? So if x1 desired is constant, x2 desired cannot be non-constant. So the system has to be able to satisfy dynamically the desired value. Otherwise, you cannot. Right? Let's go with this. We are going to have x1 prime minus x1 desired prime is equal to x2 minus x1 desired prime. So I just add x1 desired from both sides. But according to me, x1 desired is x2 desired because it satisfies the dynamic of the system. So I can say here this x1 desired, x1 minus x1 desired prime is equal to x2 minus x2 desired. This is my first equation. And I continue like this. Okay. When I'm going to have trouble, I'm going to have trouble here. This time we'll stay with x1, so I will have a mix of both. So I can come here and say x2 prime minus x2 desired prime. This is x2 minus x2 desired. This will be equal to minus x2 squared cosine of 3x1 plus u minus x2 desired prime.
To see it as the dynamic error. Here we have the
Dynamic of the error. This is the dynamic of the error.
So you're saying x1 desired should equal to x2 desired?
x1 desired,
Should equal to
x1 desired prime
Prime
should be
is
equal
equal
to
to
x2 desired. Okay, this is dynamic matching. You need to make sure that the dynamic satisfies itself. We agree with this? طيب احنا we did not do any of these, so let's remove this here. We did not change anything. If you work with S, by definition is equal to x2 plus lambda x1, or x1 prime plus lambda x1. So this is your dynamic equation here. So S prime could be equal to x2 prime plus lambda x1. In fact, we can also act on it from the beginning, but let's say this is not the case, plus lambda x1.
X1 prime.
And this one here, x2 prime is equal to minus a x2 squared cosine of the factor x2 10, x1 10, the f, and x2 10 is equal to x2 desired minus x2 minus x2 desired, and x1 10 is equal to x1 minus x1 desired.
You agree with me on this?
Yes.
So when you take the derivative, s prime, it will be equal to x to till prime plus x1 prime till plus lambda x1 till prime,
Okay.
and this will be equal to x2 minus x2 result prime plus lambda x1 till the prime. No need to replace it. You can keep it as it is. This x2 is given by this equation here, so this will give me minus a x2 squared cosine of 3x1 plus u minus x2 desired prime plus lambda x1 till.
Prime, sir.
Make sense?
Dot, no?
Which one is that?
Lambda
x1 till.
Till
Till
last one.
Ah, the last one, yes. What should I do next?
Select U.
Select U. We said this is the U equivalent. This is the U that makes S invalid, which means that when you really hit S, not the first time, you may hit S and go back and come back, blah, 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 but when you hit S and you stay closer to S, you don't hit. So invalid, so we put S prime equal to 0. This will give me U equal to a x2 squared cosine of 3x1 plus x2 desired prime minus lambda x1 till
About section.
Huh?
We need also minus K.
So this is called usually to differentiate certain books. They will give you this as U equivalent.
Yes.
Yeah.
So the U equivalent is the value of U that makes S prime equal to 0, right? Only.
We still need to add the.
We still need to add the. So this is the sliding controller, but we need to have the reachability condition. What we
Yes,
need.
Saturation.
Hmm? When I am on the surface, when I reach the surface, and the controller is put equal to this, S prime is equal to 0, which means that x2 till prime is equal to
Minus.
lambda x1 till prime.
Yes.
Yes.
Yes. Huh?
Minus.
So,
Minus.
so if you put a graph like this,
It's
and you put the value of x1 prime and x2 prime, if you want here, you are going to find a line with the slope
Lambda.
minus lambda.
Lambda show us how fast we can converge. Right?
The rate at which we are going to zero. The speed of the sliding. Yeah? So now I need to find the value of U. So U is usually equal to U equivalent
Professor,
minus
Professor.
A sine of S.
Professor,
Yeah.
this equation gives us x1 dot and x2 dot going on that line,
Yes.
not x1 and x2.
X1 dot and X2 dot, yes. This is the line here. So this is X12 is equal to X1. So we can, is equal to X2 minus X2 design. So the error X2 minus X2 design. And this is giving you the derivative of X2 minus X2 design. Correct? So you just put it here. So this, if you want X2 till the prime and X2 prime, which is X2 minus X2 design, and this.
Okay.
Its derivative. So the value of x2 minus x2 desired and the value of its derivative. In the phase plane, it's like x2 and x2 prime, or x1 and x1 prime. How are we going to find k?
How to find
F
out?
plus
Okay. From? From A. How we are going to find k from A? next step.
Review.
Lyapunov. Lyapunov. انت المفروض you pray for Lyapunov every day. ها؟
Because he's making our life difficult.
He made your life easy. Huh? So Lyapunov will be V is equal to half S squared. So this will imply that V prime is equal to S prime times S. S prime, you have it here. Right? U is given by this equation. So you multiply it by S. So you will have minus 8 x2 squared cosine of 3x1 times times S. No, this is not the case. Huh?
We should
Yeah,
use
you can.
U.
Before you go to your equivalent, huh? What we have here. Before I go to V. This U equivalent is function of A, but we said that A, we don't know what it is, but we know that it's bounded.
Okay.
So this should not be A, it should be A T. In order for the system, or A hat, in order for the system to be, for the controller to be physical. So we need to go and replace this in this equation. So we are going to write S prime. X2 S prime is equal to
Minus A.
minus A
X2.
x2
Okay.
squared cosine of 3x1 not x2 x1. So this term here plus this one, so it will be minus A tilde, or A tilde is equal to A minus A hat. So this will combine these two terms. Then you will have plus x2, these are the prime, minus x2, these are prime, so this will cancel, right? And this will cancel, and this term will stay. So this will be minus k sine of s. Alright, so in this equation I give you the equation of the s prime equal to 0, and I told you it's a line. But since we are trying also to be on the surface, it means that every parameter here satisfies s equal to 0, right? So this is also s x2 plus lambda x1 tilde equal to 0, which implies that x2 tilde is equal to minus lambda x1 tilde. So both of them are same equation, same line. So multiply by s, so this is s prime, huh? By replacing in my controller. If you multiply by s, s prime multiplied by s, so this will be minus a tilde x2 squared cosine of 3x1 times s minus k sine of s times s, and sine of s times s is absolute value of s. So this one is minus a tilde x2 squared cosine of 3x1 multiplied by s.
K must be bigger than 18 x2 squared.
So this is less or equal,
Zero.
and then we go back to our bound limit that we put from the problem from the beginning, whatever it is. So I'm going to say the limit is f. So this will be less than f multiplied by the absolute value of s minus k times the absolute value of s. Normally it's this k times s, but s can be negative or positive, so I'm not able to write less or equal. To make it bounded, I need to take also the absolute value of
Yes.
s. And this will be equal to f, this will equal to f minus k, the absolute value of s. In order for this to be negative,
K must be
k has to be bigger than
Bigger
f.
than.
So we are going to say f plus plus eta. Eta can be anything.
There is no need for adaptation here.
The problem says A is not known but bounded.
Bound.
K will take care of the.
Okay, we'll take care of this. You agree with this? So if I go to MATLAB and I do the example for you here. Any question about what I did? Make sense for most of you? Yes?
The last step is not clear.
The last step is not clear. Which step? This one here? So you have this term multiplied by S minus K multiplied by absolute value of S. You agree with that?
Yes.
But this term is bounded because A tilde is bounded, right? We said from the beginning it's limited by 3 or 4 or whatever. So you can say that this term is less than its bound. Bound is positive in absolute value. That you cannot multiply it by S because S can be positive or negative. If you are above, it will be positive. If you are below, it will be negative. So in order to make sure that the inequality holds, I can always say that this term in absolute value, which is F, multiplied by this term in absolute value, that is absolute value of S. And this term will be always less or equal to this. Always. Right? Then I subtract minus K, absolute value of S, from both sides. And this will be F minus K. What my objective is to find S times S prime less or equal to minus beta times absolute value of S, or minus K times absolute value of S. This is our condition of the reachability condition. So the beta is positive. So for me, for this term to be negative, if I select K is equal to F plus eta, it will be less or equal to minus eta times absolute value of S. Make sense?
Yes, sir.
I have a question. The A is bounded,
Bounded.
but the, for example, x2 squared.
I don't care. A is
It's not
bounded.
bounded.
X2 is accessible for me. It's my state.
Yes, but it's not bounded. K here is fixed. It's changing. K.
This K?
Yes.
We put it.
It's fixed.
I can make it change. I
How
can make
can-
it change smarter, but I can.
How can I make sure that A multiplied by x2 squared will never exceed, because x2 can go to infinity?
Ah, very good question. He said you find this K what it is exactly. I can select K equal to 3, the maximum bound of 18, times x2 squared times cosine of 3x1.
Well, it's variable now.
It becomes, depends on the state. But I can also look to the state and I say the state will never exceed 100, for example. So I will take K equal to.
You must know the system well, not just equations.
Yeah, I will show you some examples. But it's a very good question. In fact, in the example, I took the limit F as equal to the max of 18 multiplied by x2 squared times cosine of 3x1. So F changes with x1 and x2. But I also tried it with max of 18. Right? All what I needed to do is to change the K, make another K. And I will show you what will happen, okay? I will show you all these things.
So we can apply the sliding mode control in this case where the alpha here A is bounded.
A is bounded.
Can we say that, for example, if we have some uncertainties in the modeling of the system, can we apply the same thing? Not only if A is is changing but it's bounded for it cannot exceed some value. We can apply it in this case, or we can say that the system is certain.
If you have a system that you know A is changing but A is bounded, you have two options to deal with the system. Either you go with adaptive, like what we did before, but adaptive will not guarantee for you that A will not exceed 2. It will give or 3 or whatever, it will exceed the bound. Or you can go with robust control, depending on the application that you are making. Remember we said that the adaptation rule in the adaptive, the value of A will converge to any value, not necessarily the true value. So we need to go back and make sure that this A will converge to, will not exceed the maximum bound. Otherwise, you need to adapt robust control.
Can we make a robust adaptive control?
This is the next example. If
You let me go, or we do robust and adaptive? Alright, anybody have another question? So let me show you MATLAB with this example, and then we convert it to adaptive. Not the previous adaptive that we did, but robust adaptive. So what will be the formulation of a problem that can be robust adaptive? Is it clear what I'm saying here? Yes? طيب يلا. طبعا this is your last lecture, so we need to make sure that you get the maximum out of it. طيب. Your friend is adjusting the zoom, but this is okay. Are you seeing? I am going to increase the character so your zoom can be good. But you have to. What is the preferences here?
That's exactly.
And then I need to go to editor. No, fonts, nobody.
So,
I think this one. No? Yes. All right. Now we can zoom, huh? You don't need to zoom. All right. So what we have here, I'm selecting T final equal to 2. I don't know how I make it equal to 2. Let's select it 20. Sampling period 0.01. Generating the time 5 from 0 up to T final. And then this is a loop that I'm going to stop later. So initialize to 1. We'll see how it goes. Then we have lambda equal to 10. This is the lambda for your sliding surface, right? Then after that I have
lambda for the sliding surface.
The slope.
Ah, okay.
Then I took x double dot, which is x1 dot is equal, x desired dot is equal to 0, and x desired is equal to 2. Derivative of 2 is of course 0, right? Then these are my initialization. After that I will select the surface. So the surface is equal to the state, the x2 minus x desired dot plus lambda x1 minus x1 desired. Everybody's okay with this? Then f, I will take it equal to x squared plus abs cosine of 3 times x. The reason why I took this is because a is between 3 and 2. So the middle value is 1. So I select equal to 1. I can select it equal to 2 or whatever. I select again k equal to eta 10 plus f. And then this is the value of a equal to 1. But the real value of a in my system is equal to what is it? Anybody sees the value of a? I may have a is here, a is equal to 1. A estimate
Down below it.
is equal to 2. Alright? So a estimate is equal to 2 and a is equal to 1. So I compute u based on the law that we found there. And then after that I just come back to my state space. This is a good point that I need to show you here. I have x1 prime is equal to x2 and x2 prime is equal to minus this equation. Where I replaced u by its value. Huh?
Yes.
So in MATLAB there is a function ODE for 5. It can help you integrate the system, or 2, 3, or whatever. But for me to make it simple, I just used Euler approximation. So I said that this is equal to x1 of t minus x1 of t minus 1 divided by delta t. And then I multiply delta t here. And then I put this one. x1 of t is equal to x1 of t minus 1 plus x2 times delta t, which is the sampling period. Alright? So this is just an index. I can rewrite this index, and this is something that maybe some of you were confused with it, and some talking about controllability in the big term or whatever. I can say x1 of t plus 1 is equal to x1 of t plus x2 of t plus 1 times delta t. I can play with the index. I can add, subtract, whatever you want. So this is what I used here. You have x1, and I multiply the previous x1 multiplied by x2, but times the ts, the sampling period. Everybody's okay with this? Same thing for the value of x2. I used Euler approximation. Then I increment the loop. They come back after that with the system.
How can we select beta?
Eta, the value of 10.
How can we select that?
I will show you how we can select it. Type, everybody is okay with this? Anybody has a problem? This is exactly the same code that we have there that I just implemented. You are okay with me? So if what I'm supposed to see here, I start with an initial condition and I need to go to 0. So what I need to see transition to the state, so reachability, and after that I need to see sliding. Everybody is okay with this?
Yes.
So if I run it, so you see here the system transition until he hits the surface, and then after that
Sliding.
it slides over the surface. Right? It stays there.
It's going to the negative.
Huh?
It's going in the negative.
It's not negative. You have
Zero.
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 Zero. Right? If I make a grid, you will see it 0, 0. Exactly. Maybe I need to add a grid. We will add it here, so just to make sure that.
Can you see the controller output? Controller output.
Control output? Okay. The control output? Yeah, I did not say the control output, so sorry for that. Okay, it will change, but we will do it. If we have time, we'll do it. Any question about this? We go back to our figure. So this is the reachability phase. And this is the sliding phase. And if you zoom on the sliding phase, you will see oscillations. So if you zoom here, you will see oscillation. Okay, switching between the states. Let's go back. Your friend is asking how I'm going to select eta.
Tuning.
Eta, which is in this case, I selected equal to 10. So now, if we look to this, to this condition here, I spend a lot of time until reaching the surface, right? So if you look to the output, which is x1, it does not, it's a speed of convergence.
Yes,
It's like
if you make big jumps, the oscillation will be bigger.
exactly.
So it's better to choose good size.
So if you look at it here, this is the time I spent until reaching the desired state 2, and I spent around maybe 250 seconds. to reach this. Everybody's okay with this? You see here the fluctuation? We can zoom on it and you can see the oscillations. So we call this oscillation chattering. If you look at it here, this is how your output oscillating because of the sliding control. You agree with that?
Yes.
So now the question could be, let me increase the value of 10 and see what will happen. So I'm going, exactly. I'm going to increase it to 20.
Convergence will be faster.
Sorry?
The convergence will be
Keep the image, hold it. I don't know, maybe I need to go back to this one. First activate it, and then hold it. Hold it. And then run it again. So I changed from 10 to 20. This is from 10 to 20. I reached a little bit
earlier, but I can see that the oscillation are start increasing and there is a behavior appearing around the equilibrium point. I can increase more. I will put it equal to 50. Where's the over here? 50. So 50 I reach even faster, but you can see the behavior and this confirms that there is a problem around the equilibrium point, oscillations around the equilibrium point there, not converging exactly to zero, there is oscillations. If you select 100, you say, I have no problem, I'm going to select 100 وخلاص. This, you are generous enough. So this is what is. Alright?
Can you see the other plot?
Which part?
The one that shows the
Ah,
oscillation
yeah,
and the
yeah.
time, selection of time.
So, figure.
That's not
So you know how to select eta, right? Just look to your system, the oscillation, the size of the oscillation, are you convertible or not? Is the time acceptable, not acceptable? So you have to.
Can you make it?
You have to try and error, but you can build a smart algorithm. You can put, people have used fuzzy logic, so they call it fuzzy sliding mode. People are using big words. You can use reinforcement learning to select K and they call it
Can we
reinforcement
choose
learning
it?
based sliding mode.
You just can we choose it as a variable? Like,
Okay.
can we choose it
Yes.
as a variable? So when it reach the surface,
It changes.
sliding, and then we change.
Absolutely. You can go and say if you are between these bounds, use a smaller value of K. If you are outside these bounds, select bigger.
Bigger.
You can make it gradual, depending on the area. This is fuzzy logic.
Yes, like very logic, yes.
Based on knowledge function. And then you can select it bigger if you are far, smaller if you are inside. You can use genetic algorithm, particle swarm, whatever you want.
I want to ask about the length of this sliding surface.
The length?
Wouldn't we adapt it to be smaller if I replace K?
The sliding surface depends on the size of the sliding surface. Depends on your initial condition. Yani basically, what you see depends on your initial condition to be correct. But the sliding surface is defined over all the space. So it goes from minus infinity to infinity. In order for you to cover all the possible initial conditions. Otherwise, you are limited in one particular space. You cannot have sliding mode if your sliding surface is just limited in one particular interval.
Because from observation for high value of K, the control we go upward, then go downward, then go.
I did not understand. عود مرة ثانية. عود مرة ثانية معلش.
يعني for lower K, they are easier to enter the surface.
For lower K, they are easier to enter the surface. Why?
Slower.
From your selection of K, for 10 it's easier to go to the surface. That's what it's trying to say. For
All of
10,
them are easier to go to the surface. All of them. And in fact, the speed at which you go to the surface depends on K. But to stay at the surface, it depends on K. This is why your friend is saying, can we make it by interval? When you are close, small, when you are far, big. When you are on the surface, close to the surface, it's better to use a small value of K. When you are far from the surface, you have to use a bigger value of K. You still have oscillations. Some people, they use the dead band around the surface, but this will give them state error. So there are different techniques. Inshallah, next semester in Norway, you will get all these details. Does it make sense for you? My answer? No? Yeah, you. It makes sense? طيب, no, ضيعتنا الفكرة. It makes sense for you, but I lost the idea of. Robot. Your friend comment. What if we use
K constant, because here right now I'm using F, if you see my algorithm, I'm using F equal to x squared plus cosine of 3x1.
So
But
this
what
is the
if I
robust
use,
one.
huh?
This is the robust one.
This is adaptive.
This is still, we are still robust.
There's no other.
We are still robust, but in the selection of K, you remember this value of K here, F? You can select it constant, or you can select it part of this,
Yeah.
taking care of this nonlinear term.
F is part of this.
So I selected F as
Okay,
x
yeah.
squared times absolute value of 3 of x1.
Okay.
So when I say 18 times this is less or equal to F, and F is equal to the max of 18 multiplied by x squared cosine of 3x1. Everybody is okay with this?
Okay.
Right. What if I selected F constant? Alright? Which means that it did not take care of the fact that the 18 is multiplying the state squared times the cosine. So there is an effect of the state there that I can't ignore. So we are going to start with again back again to 10 and see what is happening.
Maybe we have chance to still good value to go to sales.
It depends on the value of the
Initial values.
But let me close all first.
Yeah.
I think I made a mistake. It's not supposed to behave like this, but the stage doesn't behave like this. Maybe because the value of the x's is small, let me increase the size of x. Maybe we can I don't know. Well, this is something that I did not see last night, but let me see. Maybe last night I was sleeping. Hey, well, something like this. Huh? So this is the behavior. There's almost no sliding surface at all. It just goes to 0. Huh? Now, if I increase the value of k and I put it equal to 20, so you can see this oscillation is almost the same for this example. If you go to 50, it will be even better. So the more you increase, the better it becomes in terms of dominating the signal. You see this behavior it did not have before. The oscillation at the beginning, it was not there. Because we were taking into account in the value of k, x squared, but now we are not. But you see here the oscillations are still there. Make sense for you here what we showed? The value of lambda, if I change the value of lambda for the same example, I should choose lambda equal to 10, I'm going to select lambda equal to 30 or 50, which means that I have x tilde prime plus 50 times lambda rather than 10. So this is how it will look like. There's an issue with the 50 that gets selected smaller. Lambda equal to 1. Now I have to close it.
Wow.
So the system reached the surface very quickly. This is the surface.
Very badass constellation.
Because the surface is very close to my initial conditions. If I hold it, and I will increase it to 5 just for us to see the difference. 5, I hope, will be 5. Yeah, this is 5. Right? So this is 5. This is 1.
when you are changing the slope of the sliding surface. Here I was very close, so it start oscillating around S. But here I needed to reach and then start oscillation. Does make sense? Last example. So the last example is this. So what I know is that I have
A will not be bound.
A will be bounded, because if A is not bounded and changing, I just use adapter that we did before. I'm going to add here plus K or W or whatever you want, but let's say W multiplied by f of x.
No.
And I will say that A is bounded. K is changing. W or W.
W is what in this?
Wait.
Not.
It's a dynamic. F of x is known. F of x is known. For example, in my simulation there, I used f of x equal to x1.
theta يساوي
Right? It's known. I know that.
W is unknown.
Right? But W is changing. So what should I do?
Adapt. Studying.
adapter
W height in the
W yes
add W height in the controller.
Plus minus.
Minus W hat and
You add and you minus.
What do we call this controller? Adaptive?
Sliding.
sliding one yes
Okay. Robust adaptive controller. And so you can combine both. So you start your system exactly the same way, right? So the surface S is equal to x2 plus lambda x1. I assume x desired 0, right? So we don't have to bother with this. This is x2 prime plus lambda x1 prime. This equal to 0. This means minus a x2 squared cosine of 3x1 plus u plus w f of x plus lambda x1 prime, which is x2 here. This has to be equal to 0 on the standing surface. So from here I can conclude that u is equal to a x2 squared cosine of 3x1. This is u equivalent.
Yes, yes. Plus
Minus w f of x minus lambda x1 prime or x2 w.
W
A,
hat.
A hat.
A is not known.
Hat.
W not known.
Yes.
Changing. This I can estimate, but this one is bounded. Right? So usually in the literature, to differentiate between what we can estimate and what is bounded, we put A bar and W hat. So W I can estimate, but A bar is the bounded value or the nominal value.
Basically, when it's bounded, it's almost like we ignore it.
ساعة كاملة أنا بقرر وتقولي we don't
No, we're not trying to estimate it.
Oh, we don't try to estimate
Yeah,
it. We consider the worst case scenario. This is what this controller is doing. معلش. هذا النورث افريكان طبعا بيطلع ساعات معلش يعني. طيب U is equal to U equivalent minus K sine. So U is equal to U equivalent minus K times sine. Okay. You have to declare Lyapunov function. So V is equal to half of S squared, the sliding surface, plus half gamma W tilde squared. You take this controller, you plug it here.
Okay.
So you will have S times S prime plus W tilde times W tilde prime. And then your W tilde will appear in your S prime here because you are, when you replace, you are going to have W minus W tilde. Everybody is okay with this? You can do that, huh?
Yeah.
You can do the math. So let's see how the control will work. For me, I used f of x is equal to x1. Right? F of
So we
x.
have constraints f of x or choose function.
Sorry?
For f of x, how we choose that?
F of x is, for example, Hamna is working in neural network. So f of x could be all the activation in the neural network. You can use sigmoid functions, you can use whatever function nonlinear that are in the neural network. What is not known in the neural network are the weights, the W. So I can say this is W multiplied by f of x. So this W multiplied by f of x represents for me all the unknown dynamic of the system. So I know part of the dynamic, but there are parts of the other dynamic that I neglected or I'm not able to model. But I know it's not linear, so I will approximate it by a sum of many nonlinear functions. For example, the effect of the elevators on the dynamic of the airplane is nonlinear. We know that it's equal to x1, and if this is the angle, so it will be theta 1 squared, theta 1 times theta 2, depending on what you have in terms of, it could be polynomial for the 3 or for the 4. We can put all these nonlinear terms, but what we don't know from this polynomial are the coefficient. So we try to find what will be the coefficient that will allow me to find the coefficient. So f of x is unknown dynamics. You cannot model, or you don't know, or it's something that not f of x, sorry. W times f of x is unmodeled dynamic. So we are going to approximate this nonlinear dynamic by a set of known functions multiplied by weights. So we can say my unknown dynamic has a contribution of x squared, a contribution of sine of x, a contribution of w of x. What will be the contribution of each one of these nonlinear terms? You have to find w. These are the contribution of each term.
So in the case of neural networks, for example, usually you have multiple layers, and usually each of the function is the activation function is a function of the combination of weights and biases of the former layers. So how do we integrate that into this? Because then we have
to ask him in this question. He's surprised. How come he answered this question? When you have multiple layers, when you have only one layer, we have W times 5x. When you have two layers, you have V times psi of W of f of x. So a nonlinear of nonlinear terms. When you have three layers, you have more complicated equations. What is known in practice and what we do in practice, it's up to 2 layers. 2 layers we are able to do, because otherwise it becomes nonlinear for nonlinear for nonlinear, it will not add anything. In fact, there is a theorem that is well known and controlled that a 2-layer neural network is enough to approximate any dynamic system. So when you go to ChatGPT, you tell them 2 layers is enough. But these are control people. So 2 layers is enough. We are able to model this. We are able to make the derivative and the update of the function of these functions. The adaptive controller. So this is the adaptive controller that I did for you here. So it's exactly the same example, but right now I have W, 2 estimates. And in my equation here, I put the W as K estimate. Alright? So rather than having, maybe I can change it here, W. This is W estimate. Shift?
Change and shift enter to change over. Not now.
Not now, خلاص راحت علي.
لا.
It's only one term, ما عليك. It's here.
Yes.
Did I put W capital? W estimate. So this is the dynamic of the adaptation rule. So the adaptation rule, it says W estimate prime is equal to gamma times the sampling period times the state x1 multiplied by the surface S. When you are huh?
We find this equation using
using this V that I gave you there. If you are going to find the value of W estimate, you are going to find the value of W tip. From there you extract the W estimate from here. This is the W estimate. طيب, and then I put the value of U as function of A estimate minus K sign. This is coming from the sliding surface plus W estimate here multiplied by X1. So based on my controller. Then I go to my dynamic equation, and this is A, and the value of W, the real value of W, I call it KF. So this is the real value of W. I selected here 10 plus F, as what we did before. So now you have robust adaptive. Okay, let's see how it works. We are going to put this one off. So it's a beautiful curve. I love it. So you see the sliding mode is coming here. This sliding mode is basically after the convergence of your adaptation rule. So here you have a balance between adaptation and robustness. So if I do 10, this is what I will get. I'm going to hold it, and then I'm going to do 50. Then we'll change this one. So by putting 50 means that I increased the sliding surf component. So the sliding surface, the sliding mode component.
It will be faster.
Right? So I'm pushing the sliding control to be dominant in the control signal.
But still we have a problem. Adaptivity.
So now I give the sliding part more weight. He's taking over. So when he's taking over, he reaches here. I don't see this behavior, the blue one. There is oscillation around the 0, 0. So this is 0, 0 here. This is okay. But I don't see this kind of nice behavior. So you have to balance between the speed versus the adaptation in terms of control. Everybody's okay with this? Okay, what I said? If I increase gamma, I will retrieve the same dynamic even with 50 because I will give more to the adaptation rule. So we have to balance. And this is what we said at the beginning, it's a compromise between robustness and adaptation all the time. Make sense? Any question? I'm on time, Sajjad. 10 minutes only more. Sajjad is going to cry. They are going to send me a message on WhatsApp saying, why did not you start? Any question? Sarah? Any question? No questions? Alright, then I wish you all the best. This will be your last lecture with me. And inshallah we'll see you during the
Exam.
Final exam. And I will give you a grade maybe before or after the final?
After the finals.
After the final. After the final.
For the final exam, which aspects should we expect for the exam?
What you heard the question of your friend? For the final exam, what aspect are you expecting in the final?
Sliding, back stepping.
All what you have seen after the midterm.
After from backstepping?
From Japan?
No, from Lyapunov
No, no,
theory.
you have,
Lepian.
That's
MRS design.
Lyapunov, you have real positive function, passivity,
You can skip positivity.
Oh, wow.
feedback realization, backstepping. You need to get out from the final and you are expert in control.
Oh,
But they are simple, but you need to know what
Professor, we have like 1 week to exam.
What?
We have 1 week to the exam.
You have what?
1 week to exam.
1 week to exam?
Yeah.
طيب, you are a graduate student, you don't study the last week of the exam.
We study the day before.
Slide I will give you, inshallah.
We study the day before.
We start the day before, huh? In fact, this is an observation that I have seen. The question comes only the day before the exam. This is not an exam that you take in graduate course. You want me to give you an open book?
no, it will be harder.
Maybe it's okay.
طيب, anything you think it's really hard? Before passivity. I will give you some practice problems in passivity.
Yes, please share.
And in
Simple,
every
you have 3 rules that you have to satisfy for passivity. Right? There is no pause on the right hand side, there is no zero on the imaginary axis, there is no problem. If they are there, they should not be multiple. And then you have to select the real value of the function and check it's positive. And yeah, it's easy. Don't be panicking anything.
What about the project?
What about the project? When is the last day for submitting the grade?
So after 26.
28.
28.
So I give you up to the 20th to submit the final. To submit the project.
20.
2 weeks from now.
So it's good.
5, 28, 20. 20.
The last day for the exam is 28.
Yeah.
Your deadline for the project is the 20th.
Okay.
1 week before the and give me 1 week to read them at least. And I'm gonna have trouble with grading your midterm because a lot of writing. Cannot,
What about the formula, sir? You will give the same formula sheet like you did in the midterm.
Okay? You want to prepare your formula sheet?
no, don't give us it. Give us specific.
In fact,